stationary points, there's something we call local maxima and minima. Now this curve can go on and on and on in whichever direction. When we talk about the local maxima and minima, we're basically talking about these stationary points that are being considered. Right? Now, let me show you something about, let's look at this point here. Let's call this point X. Now, this will be a local maximum point. As you can see, it's sloping upward. But let's look at the behavior of the slope as we go closer to the point X. If I wanted to draw the tangent, look what will happen. This tangent will be like this as I get closer and closer. Excuse me. So basically at the left side of the point X, this a line that's sloping in this direction. Is it positive or negative? The gradient positive or negative?
So positive?
Yeah, it's positive. And how I always remember positive. Remember we read from left to right. So we start reading here. You're starting low and you are, as you go further right, you're going up. So it's like a bank account. It started small and with time the amount of money increase. So any line that's sloping forward is positive because you're starting low and as you move, you're going higher. Is that clear to everyone?
Yes, sir.
Right? So as you can see here, on the left side of the point X, the gradient of points as we get closer, the gradient of these the gradient of the function, sorry, is positive. You'll get positive values. When we reach to the stationary point, the gradient, and I want you to try to understand this, the gradient will be a horizontal line. And do you know what happens when the line is horizontal? What's the gradient of a horizontal line?
So the origin?
The gradient. So it has to be a value. What's
Zero.
the gradient of a horizontal line?
So one will be 0. I don't know if it's the X or Y.
It could be, let's look at it because it's an important point that we should know. So let's say this is the point 2 on Y. And this is probably, let me call this 5 and call this 10. No, well, 10 can't be there. There's going to be 15. Right? So let's look at this line AB. AB is a horizontal line. Quickly, please find the gradient of AB. The point A is 5, 2. And the point B is 15, 2. Okay? What would be the gradient of this line? Anyone? Come on, someone talk to me. What's the gradient of the line AB?
So y2 minus y1 over
Yeah.
x2 minus x1.
Good. So it will be 2 minus 2 over 15 minus 5. And what would be your answer?
0, sir?
Yeah, 0. Because we're 0, 15. So any horizontal line will have a gradient of 0. So we see before the maximum point, to the left of the maximum point, the gradient is positive. At the maximum point, the gradient m would be equal to 0. And look what happens after when we go to the right now. Look at the slope of the line. What do you recognize?
So it's moving.
Going downwards, sir.
Yeah, therefore, you have negative gradient. What is, sorry, I put positive again. You have a negative gradient. So why I'm doing this, I want you to recognize the behavior of maximum points. So you know a point is maximum. Forgive the noise with the dogs, please. If the behavior of the gradient before the point is positive, at the point it's 0, and after the point the gradient should be negative. So for a maximum point, you move from a positive value to 0 to a negative value. Now let's see what happens at a minimum point. So let's call this point P. Before the point, what is that gradient? What's the gradient of that line I drew?
Negative, sir.
Yeah, it's negative. It's a falling line. You start high and end up low. So you move from a negative value just before the point. When you reach the point, the gradient, of course, because the tangent is horizontal, the gradient is 0. And after the point, look what's happening. What the gradient looks like after the point?
Positive, sir.
Positive. So for a minimum point, the behavior is you move from a negative value for the gradient to 0, then to a positive value for the gradient. Right. So I just wanted you to see the behavior of maximum and minimum points. Now, how is this useful? If you know a point on a graph, let's say the point on a graph is 2, 7. And this point, you want to know if this is a maximum or minimum point. You were told it's a stationary point, right? So if you want to know if it's a maximum or minimum point, this is one of the things you can do. Let's say the function is y is equal to mx cubed plus nx squared minus c. I'm just making up something here. If you want to know if this stationary point is maximum or minimum, what you can do is take a value just before the x value. So give me a number that's just before 2. Just before 2.
1.9, sir.
Yeah. So for example, we could see the behavior of the function as x is equal to 1.9. Then we can look at the behavior of the function or the gradient of the function at the point just after 2. What would be a point just after 2?
2.1, sir.
At 2.1. Right? So when I put this into my gradient function, let's say I get at x is equal to 1.9, I get a positive value. And x is equal to 2.1, I get a negative value. This is for my second derivative though. Then if I start from a positive to 0 to negative, positive to 0 to negative, as you can see what fits in there, a maximum point. right? So that's one of the ways that you can figure out. I'm jumping it, right? I know I'm all over the place, but that's one of the things you can do to figure out where a point is maximum or minimum by just substituting. Let me see if I have a direct example. Yeah. So let me see if I can get GeoGebra and show you, because I really want you to understand this. GeoGebra Classic. All right, so let's look at a function. X squared minus 5x plus 6. So let's look at this function here. The maximum point seems to be, can anyone read that off? It's actually a minimum point. Can anyone read that off? Yeah, I think that's it. 2.5 negative 0.25. I just mentioned. What? Now, when we differentiate this function, we get the gradient function. Can someone tell me what the gradient function is?
So 2x minus 5.
It is 2x minus 5. Very good. Good. So let's pretend we did not know. Where am I? Back to GeoGebra. Yeah, let's pretend we did not know that this was a minimum point. And you were given the point 2.5 negative quarter. (2.5) negative quarter. And we were told that this is a stationary point. And they'll ask us to determine whether it's a maximum or minimum point. Now, what we can do, if I look at the behavior of the graph of the gradient around this point, 2.5. So let me take a point that's just before 2.5. Someone give me one quickly.
2.4, sir.
Good. So let's see what happens at, what's the gradient at 2.4? dy dx is equal to 2 times 2.4 minus 5. So I want to just calculate that quickly. We see right away that the gradient before the point is negative. So we see right away that the gradient before the point is negative. So we start with a fallen line. At the point 2.5, we know the gradient will be 0. So that will be a horizontal line. And let's see a point just after 2.5. So what would that be?
2.6.
Just after 2.5.
2.6.
Yeah, 2.6. So let's see what will happen. 2 into 2.6 minus 5. So that will be 5.2 minus 5, which is equal to positive 0.2. So you see what happens just after the point, the gradient is positive. So with that understanding, we know that it was a minimum. Is that clearer now with everyone?
Yes, sir.
Yes, sir.
Right? So we can use the gradient, the behavior of the gradients before and after the point to determine whether it's a maximum or minimum point. Now, there is one other thing that you need to know, and it's called a point of inflection. Right? So the point of inflection may look like this. Let me see if I could remember how to draw this. I did this a long time ago. Yeah, something to that effect. Right, so the point of inflection, what happens? Let's look at this point of inflection. Let's call this Q. Before the point Q, what is happening, the gradient here, is positive. Can you see that?
Yes, sir.
Now, after the point as well, the gradient is positive. So with a point of inflection, we can have two scenarios. It's neither maximum or minimum. But at the point of inflection, the gradient is 0 as well. But I didn't draw the point of inflection properly, but the gradient is 0. But the changes in the function would either be consistently positive or consistently negative. That's a point of inflection. So this is why it's important, because when you're finding the stationary point, whether it's maximum or minimum or a point of inflection, whether it's maximum or minimum, you might find a scenario where you say, oh no, but I get positive before and I get positive afterwards. Well, I've never seen anything like this. If you get a case like this, it's called a point of inflection. In the same way, you can get a negative on the left side, a negative gradient, and on the right side, a negative gradient. So anytime a scenario like that occurs, you call that a point of inflection. So you can have a maxima, a minimum, or a point of inflection, right? Now, did anyone hear about the point of inflection before? Any video or anything you saw it? Anyone?
Yes, sir.
Okay, so I guess you did that in class, Darish?
No, sir. I saw it on YouTube.
Oh, okay. So for the others, this point of inflection is new to you? Excuse me.
Yes, sir.
All right. So what I'm going to do, teachers, I don't know if you have any more questions. Actually, I had a conference today, so I did not get to prepare my PowerPoint.